So the next 2 years, what's going to happen? There's right now a lot of talk about OpenAI, ChatGPT. Will it change everything? I don't think that it will change everything, but it will become a substantial part of how we do certain things. So obviously we as Dynatrace, as everybody else, is thinking of how can we use this new technology. And for us, a natural way is there's still a lot of tasks that you have to do today where you have to manually work with your environment. And there's a lot of things, including monitoring, has become monitoring as code. So you can create your monitoring configuration via code. You can obviously create your dashboards via code. You have things like Ansible scripts and also your Kubernetes manifests. So there's a lot of opportunities where we can use GPT and LLM technologies to really help us, especially the last step of automation, to help us being more effective. Like, for example, you realize you have a memory leak on a Java application, you want to restart it, you could ask then an LLM or generative AI component, hey, can you generate me an Ansible script to restart a JVM? So there are lots of opportunities there. Or can you tell me how I have to modify this Kubernetes manifest to not run out of memory and increase, for example, the memory footprint? So a lot of these things I think are going to emerge over the coming years, very especially that how do we deal with what we have observed, how we put it into actions, and especially when we talk about production problems, how can we do this very quickly and efficiently? And I think these tools have already shown in coding they're not always right, but they help us, especially doing like the toil work that we have to do. Like if you use something like Copilot, looking at GitHub, reading something from a CSV file and putting it into some type of data structure, why should you have to write this? It's like boilerplate code. I think there's a lot of opportunity in the future going forward for us and how we can leverage and integrate these technologies in what we're doing on the observability and automation side. Yeah, we're doing a lot in the open source space. As you can see, OpenTelemetry, OpenFeature, and the Captain project. Why do we invest in open source? Obviously, we're a commercial software company and our job is to provide software to our customers in a SaaS fashion mostly. But there are also areas where we see more value in contributing with the community or in moving the industry forward. If you look at those projects, it should become pretty obvious. On OpenTelemetry, we want to create a common standard on how we collect and distribute telemetry data to backends. On OpenFeature, we create a common standard of how we define or query feature flags and turn them on and off with OpenFeature and FlagD. And on Captain, we define a standard on how we can observe and intercept deployments on Kubernetes to get more of the logic directly in there, or how do you uniformly access metrics data inside of Kubernetes, whether it's for an autoscaler, ACD platform, or whatever. So the common theme for us is there are topics that are important for our core product, but we want to collaborate with others and achieve an agreement and work with them collaboratively, and that's where we're investing in open source. Pipeline-less delivery. Like, what is pipeline-less delivery? You need a pipeline to deliver. Actually, that's not entirely true. What you really need is a mechanism to deliver applications properly. Kubernetes provides a lot of these capabilities out of the box, but very often triggering a test, checking preconditions and post-conditions happening outside of the core Kubernetes cluster as part of your pipeline, like the delivery pipeline. So with introducing the Captain project and intercepting this project, this process of delivering and deploying applications on Kubernetes, we can do what you mostly would put in a task in a continuous delivery pipeline, direct natively into Kubernetes. So pipeline-less delivery doesn't mean that your pipeline steps no longer exist, but they are transparent in your Kubernetes cluster. You don't need an external tool, and this makes Kubernetes more or less the overarching platform for shipping your applications. And it comes with a number of advantages. Think you want to roll out a specific process to all of your Kubernetes deployments. In some cases, you would have to touch a couple of 10, 20, maybe 100 different pipelines. In this case, you add the operator to all of your Kubernetes cluster. All pipelines, all deployment mechanisms stay the same, whether it's a kube control apply, a GitOps approach, or whatever you're going to use. and immediately get these pre-post checks and a lot of the logic that you would usually have to put outside of a Kubernetes cluster. Yeah, our open source project. Captain is the one that we have been working on for the longest, obviously except to OpenTelemetry, where we are contributing, but it's the first open source project that was announced by Dynatrace. And it also falls in this category of automation and making things easier. And it has been around for a couple of years now, but just very recently we re-engineered the project to all the changes that happen in the industry. So the latest version of Captain we refer to as the Captain Lifecycle Toolkit. What this indicates, it's not like this big platform that it used to be, but it's rather a set of individual components following the Unix paradigm. They work seamlessly together, but you can pick and choose what you want to use of them. And it's basically three things that it can do for you. First of all, you install it on your Kubernetes cluster, and you will get observability for your deployments on Kubernetes. Not just for a single deployment, but for an entire application. It means you're getting traces and metrics for everything. Just thinking you have a GitOps workflow, it failed, you want to figure out why. You get an OpenTelemetry trace, and you can do everything with it that you want. Number two is you might decide that you don't want to always deploy. Like somebody commits to Git, you have an automatic deployment that's triggered by GitOps, but there's a production incident going on. So you might check for that production incident. Or you might agree you're only deploying if you at least have a certain error budget available. That's what we do with pre- and post-deployment hooks. So these are very small snippets which we call Captain functions that you write to extend more or less the logic that you have in these environments, which removes a lot of the burden that you usually needed to build, having pipelines outside of Kubernetes and move it right in. And last but not least, for a lot of these decisions we need metrics. How do you get these metrics? Usually via open source tools like Prometheus, but also from cloud provider data like AWS or observability platforms, obviously like Dynatrace, Datadog, or Grafana, whatever you use. So what we did, we provided a uniform interface how you can query metrics and get them back in a Prometheus or Kubernetes event format, no matter where they're coming from. More or less a universal translation layer for the APIs for querying metrics, on top of what you can already do today with OpenTelemetry for ingesting metrics. Ich denke, dass es ganz wichtig ist, dass man sich versteht. So what you just saw is I give you an answer, or I talk to you, but I talk to you in German. If you don't understand German, you're most likely not getting the semantics of what I'm actually talking about. And that's why semantic conventions also in OpenTelemetry are very important. While you got the information, you couldn't understand it. And that's what you see also in the observability space. How do we talk about an HTTP request? Do we call it a URL, or do we call it the host name, the URL parameters, the method, or do we call it the request method? All of these things need to be standardized and kind of agreed on, and this is what semantic conventions are giving us. That all providers get the same data and can provide them in the same way, plus on top also define what is the minimum required type of data and that you need to properly do your work. And that's why semantic conventions are really important, because in order to live up to the idea of OpenTelemetry, that you have this one standard that provides all the telemetry data, all tools can seamlessly work with it, they need to speak the same language. Yeah, OpenTelemetry, we have been contributing to the OpenTelemetry project for a very long time. We already were involved with the whole open observability community way before that. There was obviously Open Census and other projects, obviously Open Tracing. And we started collaborating very early on, and we realized, well, obviously Dynatrace has with the one agent a very sophisticated technology to collect all of this data. We love the idea that the whole industry is collaborating on building instrumentation, agreeing on like how we collect data, providing more standards. Because at the end of the day, each vendor is kind of facing the same challenges. How do I get the best data out of a framework? A lot of this was reverse engineering. You were looking at, okay, this is how this middleware, how this technology is working. That's how I should extract data. But we always thought, wouldn't it be better if the people who built those frameworks and middleware components would do it? And to some extent they did it with metrics, but that's kind of where it stopped. And OpenTelemetry provides a great opportunity, especially for framework and middleware vendors, to expose this data across all data sources, and that's why we're supporting the project, keep investing it, being part in technical committees, governance, the governance committee, and obviously also obviously actively contributing code and supporting it as a data source in Dynatrace. So today you can send us data with one agent, which is our own technology to send us data, but you could also use OpenTelemetry. So recently we introduced a lot of new things to the market. As I mentioned before, there was this whole evolution about how monitoring API MM changed. And obviously products changed as well. So one of our biggest announcements was Grail, our new data store that allows us to store not only traces, metrics, and logs at massive scale, but also other types of data like business events and so forth, and run queries on like petabytes of data. That was one part of the announcement, or the extensions to the platform which we recently did. We also introduced automation engine, being able to automatically act on what we observe in the environment. We refer to it as like observability or data-driven automation. So based on the outcome of the analytics you do, you want to trigger very specific automation. And with the automation engine and also app engine, you can build custom apps on top of Dynatrace. Like the example where you use your monitoring data and combine it with carbon emission data. That's nothing you can show in an APM tool. You need to build like a custom application, custom screens, query different data sources, bring it all together. These are the main extensions to the platform we did to really provide this power to our end users to build domain-specific apps, run more analytics, and kind of build also the automation and especially orchestration directly in Dynatrace based on what they know about the data. At Dynatrace, we have been doing observability, monitoring APM for a very long time. And the shift was really in the very early days of Dynatrace. It was really hard to collect data from production systems without impacting them. Over the years, obviously, they shifted more and more, environments got bigger, and the focus got more and more into analytics. So the data delivery problem kind of got solved more and more. Analytics became more important. That's when we started to introduce AI on top of it. Think about it, you have like a large number of containers, some of them have a problem. You want to figure out how is the individual problems related to each other, what is the root cause, why are things working and why aren't they working. And now we see it actually evolving even further. You want to not just monitor, but you want to automate. So you want to take the output of that analysis and automatically trigger remediation, inform the right team of what to do. That's one change that we see. Also, we see security coming in much closer. With traces especially, you totally understand if you have a vulnerable container. Is it talking to a database that contains sensible data? Is it exposed to the internet? So observability and security start to naturally integrate with each other, so that's definitely something we see. And another trend is that people use observability data together with other data sources. So it's not that you just collect the observability data, which is important, but for FinOps, you might combine it with cloud cost data. For our carbon footprint app, which we recently released, you combine it with carbon emission data. So even the use cases are constantly evolving, and people are using it for more and more different use cases, enriching more data, moving more and more into an analytics perspective and into automation.